Azure Backup is a cloud-based service that delivers simple, secure, and cost-effective solutions to backup data. It streamlines data protection for Azure virtual machines, on-premises servers, and other workloads. By leveraging recovery services vaults, Azure Backup reduces the need for on-premises tape or off-site storage. It integrates with features like role-based access control and encryption to safeguard critical information. With automatic scaling and flexible retention policies, Azure Backup addresses needs ranging from short-term to long-term data retention. This service complements Azure Monitor capabilities, enabling administrators to track backup health and respond promptly to alerts or job failures. Before performing backups, it is crucial to understand core Azure Backup components. These include recovery services vaults, which store recovery points and backup policies, defining the backup schedule and retention. You also configure backup agents or extensions to manage the data transfer. Azure Backup encrypts data during transit and at rest using SSE or customer-managed keys. Integration with Azure Monitor allows for real-time notifications and analytics of backup operations. These components work seamlessly, providing comprehensive protection for multiple workloads. Understanding their functionality ensures efficient design, implementation, and monitoring of backup strategies aligned with organizational requirements. A key element of Azure Backup is the Recovery Services Vault (RSV), which acts as a secure storage repository for recovery points. After creation within an Azure region, the RSV encapsulates settings for backup and replication. It supports various workloads, including Azure VMs, SQL databases in Azure VMs, and on-premises servers via Azure Backup Server. Administrators use the RSV to manage backup jobs, retention schedules, and restoration procedures. By storing recovery points in geo-redundant or locally redundant storage, the vault enhances resilience. Additionally, it integrates with Azure Monitor to generate alerts, ensuring issues are addressed quickly. Backup policies define the frequency and retention duration of recovery points. Administrators specify which days and times backups are taken, how often incremental backups occur, and how long restore points are kept. In Azure Backup, configuring policies involve selecting target resources, VMs, file shares, or databases, and assigning the desired schedule. Retention rules can range from hourly or daily backups to yearly archival. Policies allow granular control, enabling different strategies for production workloads, development systems, or compliance requirements. Properly planned policies reduce operational overhead and ensure consistent, optimized protection of resources while meeting corporate and regulatory standards. Azure Backup supports multiple backup types, each crucial for maintaining data consistency and meeting recovery objectives. Common approaches include full backups capture the entire data set. A differential or incremental backups only save changes since the last backup. With varying scope, Azure Backup caters to virtual machines, on-premises servers, file shares, and specialized workloads. This flexibility allows tailoring backups to each environment, reducing storage costs and time needed for operations. Furthermore, incremental backups significantly optimize bandwidth usage. By choosing the right backup type and scope, organizations align restore times with business-critical demands. Performing backups for Azure virtual machines typically involves installing the backup extension, which coordinates with the Azure Fabric to create application-consistent snapshots. These recovery points are transferred to the Recovery Services Vault, allowing for multiple restore points. The backup policy determines snapshot frequency, retention length, and the type of snapshots, full or incremental. During a restore, Azure Backup can replace the existing VM or create a new instance with the chosen recovery point. This process ensures minimal disruption and retains consistent states for workloads like databases, enabling rapid restoration of services during an outage. Azure files can be included in backup strategies to safeguard shared folders stored in the cloud. By linking the Recovery Services Vault to Azure storage accounts, businesses can schedule snapshots of file shares. Using incremental snapshots, Only change blocks are transferred, optimizing network usage and storage. Administrators customize retention policies to keep critical files accessible for short-term or long-term recovery. In the context of Azure Monitor, logging and alerting help track snapshot completion and failures. Employing backups for file shares improves data resilience or complementing other enterprise backup solutions for holistic data protection. Azure supports many snapshot-based backup scenarios beyond file shares. For instance, Azure Backup uses snapshots of managed disks attached to virtual machines. Snapshots capture the state of a storage resource at a particular time, enabling rapid creation of recovery points without halting operations. Snapshots can then be transferred to a vault for long-term retention. This approach ensures minimal overhead and maximizes data consistency during backups. By combining snapshots with scheduling, retention, and alerting from Azure Monitor, administrators maintain ongoing synchronization of critical data. This process is vital for environments requiring frequent backups or immediate restore points. Restoring data in Azure Backup involves selecting a recovery point from the available listings in the Recovery Services Vault. The chosen recovery point may be for a full or incremental backup, depending on the policy used. Once identified, administrators can perform restoration to the original location or choose an alternate destination. Azure Backup processes the data transfer and reverts it to the state it was in during the snapshot. This operation helps recover from accidental deletes or corruption. Integration with Azure Monitor ensures that any issues during the restore phase are promptly identified through alerts and logs. When restoring an Azure VM, administrators first locate the relevant backup instance in the Recovery Services Vault. They select a restore point marked by its date and time. Options include restoring the VM in place, which overwrites the existing instance, or creating a new VM that references the chosen snapshot. After selecting resource group, network configuration, and destination, Azure initiates the process. Upon completion, services or data revert to the backup point's exact condition. Using Azure Monitor, you can track restore progress, check status logs, and set up notifications to ensure a successful recovery within defined service-level objectives. For Azure file shares, the restore process leverages snapshots to retrieve earlier file states. Administrators navigate to the Recovery Services Vault, choose the applicable file share, and select a suitable recovery point. Azure Backup then allows you to restore items to an alternate location or their original directory. This flexibility is useful for recovering specific folders, mitigating accidental deletions, or addressing ransomware events. If only a few files or folders require restoration, the process can be targeted to minimize downtime. Like VM backups, monitoring and alerting in Azure Monitor offers visibility into the restoration flow and its success. Maintaining transaction-consistent backups is vital for databases and mission-critical workloads. Azure Backup coordinates with a VSES, Volume Shadow Copy Service, or other snapshot mechanisms to capture data in a state consistent with pending transactions. This ensures the recovery point includes only committed operations, preventing data corruption upon restoration. For example, Azure Backup can quiesce SQL Server workloads running on an Azure VM before capturing a snapshot. Such processes incorporate pre- and post scripts at the VM level. Achieving consistent snapshots is key to restoring complex, multi-tier applications with minimal data loss and operational downtime. Azure Monitor is integrated with Azure Backup to provide real-time visibility into backup jobs. By accessing the Recovery Services Vault Blade in the Azure portal, administrators can view ongoing jobs, monitor success or failure rates, and review logs. Alerts are configured for critical events, such as backup failures or missed schedules. This proactive monitoring allows organizations to take quick action, reducing exposure to data loss. Coupled with log analytics, you can generate custom queries and visualize trends in backup performance. Understanding job patterns helps optimize policies, plan expansions, or pinpoint issues in data transfer or storage usage. Custom alert rules in Azure Monitor help track specific backup conditions, including job completion, partial successes, or storage anomalies. By configuring action groups, administrators designate who receives notifications via email, SMS, or other channels. They also create alert processing rules to automatically route or suppress certain warnings under specific conditions. These mechanisms enable quick triage when backups fail or retention thresholds are exceeded. Such proactive alerting ensures that recovery points remain valid and data remains protected. Integrating alerts with help desk systems or orchestration platforms can further streamline resolution and enhance an enterprise's overall data protection strategy. Azure Backup employs encryption at rest with platform-managed keys by default, and it can also support customer-managed keys for granular control. Administrators can enforce multi-factor authentication, MFA, to protect vault deletion or policy changes. Role-based access control, RBAC, ensures that only authorized users can manage backups, restore data, or modify settings. Soft delete features in the Recovery Services Vault provide additional safeguards, preventing accidental or malicious removal of backup data. These layers of security integrate with Azure Monitor's logging and auditing, enabling organizations to track user actions, minimize threats, and maintain compliance across industries. Automation can streamline backup and restore operations. By using Azure PowerShell or Azure CLI, organizations define scripts to create vaults, enable backups, and perform restores. For example, a PowerShell snippet might connect to Azure, select a VM, and trigger an on-demand backup. PowerShell Connect as account, select as subscription. Subscription name, example, start as a backup item. Resource group name, RG1. Vault name, Vault 1. Item name, VM1. These scripted approaches integrate with Azure DevOps pipelines, enabling continuous delivery and safeguarding environment changes. Logs from these runs feed into Azure Monitor for real-time oversight, ensuring an efficient, automated data protection strategy. Periodic testing of backups is essential to validate restore procedures. Administrators often create isolated test environments to restore production data without impacting live operations. For instance, they might use a separate virtual network or resource group to confirm that critical applications function post-restore. Confirming data integrity, transaction consistency, and performance allows proactive adjustments to policies or capacity planning. Azure Monitor logs help identify performance bottlenecks, while alerts signal if any part of the restore fails. By rehearsing disaster recovery steps, organizations gain confidence in their ability to meet recovery time objectives, RTO, under real-world conditions. Azure Backup costs are influenced by factors like data storage size, region, redundancy type, and retention duration. Leveraging Azure Cost Management, administrators can track backup expenditure at subscription, resource group, or resource levels. They can analyze cost trends over time and adjust policies, storage tiers, or retention settings to optimize expenses. For example, if long-term backups are rarely accessed, archive storage in the vault might be more cost-effective than standard tier storage. By combining cost information with Azure Monitor usage metrics, organizations balance robust data protection with budgetary constraints while maintaining compliance with internal and external regulations. Administrators may encounter issues such as failed backups, excessive data transfer, or slow restore times. Investigation typically involves checking logs in the Recovery Services Vault and cross-referencing Azure Monitor for error details. Network bandwidth limitations, insufficient permissions, or corrupted snapshots can also disrupt backups. Error codes appear in the Azure portal or can be queried through PowerShell or CLI tools. Steps to resolve problems may include re-registering agents, resetting credentials, or splitting large backup sets. Familiarity with Azure documentation, combined with methodical diagnostic practices, helps restore normal backup operations swiftly while preventing future occurrences. Establishing an optimal Azure backup strategy involves several actionable steps. First, plan a clear backup policy aligned with business continuity and compliance requirements. Next, ensure that role-based access control and multi-factor authentication protect the recovery services vault. Use incremental backups to reduce time, bandwidth, and storage usage. Regularly test recovery procedures to validate data integrity and refine operational processes. Leverage Azure Monitor for proactive tracking of backup jobs and immediate alerts on failures. Finally, manage costs through careful retention schedules and the appropriate storage redundancy. By following these practices, organizations sustain dependable data backup and swift recovery capabilities.